So we look at these rules, and then we think, okay, how do I attack this problem? Well, we're going to think about significant digits. Now that we've learned about them, we have to deal with them all the time. Then we start by writing down the units we want in our answer. We look up or we figure out the conversion factors that apply to the problem. We choose the factor that has the unit you want on top. Now that's the key. Then we multiply the unit factor by the given value and keep going as needed until all the units except the one you want have canceled. Now I'd just like to address this. I know some of you have taken chemistry before. I think all chemistry teachers in the world that I've encountered, except me, all do these problems the same way. They say to students, read the problem and start with what you're given, or start with what you know. Now, I was an unusual student. Yeah, I made it through. I have 2 degrees in chemistry. But when I started this the first time, I just remember feeling so discouraged and overwhelmed because I would read that problem and there'd be so much stuff written down there and so many numbers that I was confused. And I didn't know what I knew, or I didn't know anything, and I didn't know where to start. And I went for help, and they kept saying, well, start with what you know. And it's like, I don't know what I know. There's too many numbers here. So after a lot of aggravation, I taught myself to do it backwards. To start by looking at what I wanted. What am I trying to figure out? And I figured that if you start with that and get rid of everything else, at the end you've got exactly what you want. So I'm going to show you that way because I think it makes more sense. Now, if you look at this and you can't buy into what I'm doing, then let me know and I'll flip it around and show it the traditional way. Even though I'm really old-fashioned and pretty conservative and traditional in most things, not this. I'm backwards here. And I think backwards is easier. And when you're all smiling and liking this, I know you'll know that the backwards is better. Okay. So let's look at some non-chemistry examples to start. How many days are there in 2.5 years? Well, in order to answer this question, we need to figure out what we want in our answer. So, how many days? So somehow when I'm done, I want to have days over here. So I write down the unit I want over on the right side of the paper. And that's what has to be on top. Now, we look up or figure out all our conversion factors that apply to the problem. Well, I have the need to have my answer in days, but I have years. So we need a relationship between days and years. Who knows what that is? 365 most years, right? So 365 days is equal to 1 year. Or I could also write down 1 year is 365 days. Now, when I read this problem again, I want my answer in days. That's what I wrote down here. So days has to be on top. So which one of these is going to do the job? The one on the left. So now, if I just write that down, 365 days is 1 year. Now I think about this. I want my answer in days. So I want to preserve this unit of days. And in order to do that, I have to get rid of years. Years is on the bottom. So if I multiply by years, putting it on the top, years will cancel. Times 2.5 years. So now, year divided by year is 1, so that unit cancels. I'm left with days. Now all I have to do is multiply across. You multiply across and then divide, and I get my answer. 912.5 days is what my calculator says. Now I stop and think about significant figures. Now that significant figures are always turned on. How many sig figs were in this number? 2.5. 2. And How many are here? 3. So how many can I report? 2. So 910 days. Now this is kind of a bad example for sig figs because these sig figs are for measured values, right? And days are really counted. So we're thinking of these now as measuring a day. How many 24-hour periods, right? So these rules are for measurements. Okay, let's look at quarts and fluid ounces. How many quarts are there in 12 fluid ounces? Well, I'll put quarts over here. That's what I want to end up with, so it has to be on top. Who knows the relationship between quarts and fluid ounces? Anybody? 32 ounces is 1 quart. Okay? And again, you don't need to know this for this class. These are just everyday examples. I wanted you to feel comfortable with the process from things you'd probably know. So 32 fluid ounces is 1 quart. Or 1 quart is 32 fluid ounces. You do need to know the metric conversions for the next test. So, how many quarts are there in 12 fluid ounces? Well, if I want my answer in quarts, what do I start with to get it on top? Which of these factors will help me? The one on the right. 1 quart per 32 fluid ounces times 12 fluid ounces. Fluid ounces divided by fluid ounces is 1, so the units cancel. How many sig figs can I report in my answer? 2, because I have 2 here. So 0.38 quarts. So does that seem reasonable that you can do this by thinking of the factors, getting the one you want on top, and getting rid of everything else? Okay. Flip the page, and there are some for you to try. If you're watching the video at home, stop the video and do these problems and then restart.